Welcome back to part 2 of Module 9. I believe it's Lesson 4, where we're continuing our study of volume. And we're going to pick up with this where we left off, which is the volume of pyramids. Looking at our definitions, a pyramid is defined as a polyhedron with one base that is polygonal and three more triangular faces that meet at a common vertex. If you think about that Great Pyramid of Giza, that is what we're talking about when we talk about pyramid. The Mayan pyramids, they're not technically pyramids by this definition because they have a flat top. A pyramid has 1/3 of the volume of the prism of the same height. So if you took the prism formula, the volume of a prism, multiply it by 1/3, you're going to find the height of the pyramid, or the volume of the pyramid that way. The height of the pyramid is going to be perpendicular distance between the vertex and the pyramid to the base. So if we looked at it in words, we could say the volume of a pyramid is 1/3 of the area of the base, capital B for base area, times the height. If we were to look at a model, you can see the height is the distance from the top all the way down perpendicular to the base, and the base, capital B, is the area of the bottom, and the formula for that is volume is equal to 1/3 times the base area times the height. And that gives us example 3 for this problem. And once again, I really don't like how the textbook throws it all in there together. So let's take a minute and break it down. And we're going to have some kind of unfriendly numbers here. They did give us fractions to deal with, and I really wished when they were introducing a new concept to you, they would do it without fractions so that you could get a little better foundation. So there's our pyramid, and we're going to take and zoom in on it a little bit and let us start working on finding its volume. First thing we need to do is find the base area, and the base area is going to be a rectangular base, so that is going to be our length times our width. Now we're talking about these distances right here. We have a length and we have a width of our triangular base. So now I say base area is equal to 3 1/5 times 1 1/2. Good news is that they're fractions, not decimals, so this should be easy to work. Base area is equal to, change that mixed number to an improper fraction. 5 times 3 is 15, plus 1 is going to be 16/5, times 2 times 1 is 2, plus 1 is 3/2. Next, we're going to simplify. 2 goes into 2 once, 2 goes into 16 8 times, and we're going to multiply. That means 8 times 3, that's going to become 24. 5 times 1, that's going to be 5. And we're just going to leave that right now as an improper fraction because we're going to have to multiply that number again in just a moment. Now we're going to the volume formula of a pyramid, and the volume formula, a little different from the other one, is going to be 1/3 times the base area times the height, which means it's going to equal to 1/3 times the base area we discovered right there is 24/5 times the height, that's this distance right over here, which is going to be 2 4/5. Now I do need to change that 2 4/5 into an improper fraction, so let's go ahead and do that. And when I do that, it's going to be 5 times 2 is 10, plus 4 is going to be 14/5. And now comes some time to simplify things. I can say that 3 goes into 3 once, and 3 goes into 24 8 times. That's the only thing that's going to simplify here. So now my volume is equal to 1 times 8 is 8. 8 times 14, that's going to be 80, plus 32, which is going to mean 112, divided by 1 times 5 is 5, times 5 is 25, right here, also known as 4 12/25. So the volume of that rectangular pyramid is going to be 4 12/25 cubic inches. Jump back over to the textbook, and you can see that's the same exact answer that they got. You can put it in there if you want, but there's not much point in it when they already gave it to us right here. This, folks, is showing your work. That is what I must see on each and every one of these problems. Now it is time for you to pause the video and work this problem on your own. Go ahead and do that. Pay special attention to the fact you have a triangular pyramid here. Alright, I set my problem up recognizing that the base is a triangle, so for the base area I use a formula for area of a triangle, which is base times height divided by 2. Now I'm going to remember that my base and my height meet at right angles like I see right here. So I have a right angle right there on that triangle. That is going to be the base and the height of my triangular prism, or my triangular base. So base area is going to equal to, we'll call the 8.1 the base and the 6.4 the height. It really doesn't matter which one you do. Divided by 2, and I'm just going to go ahead and simplify that, saying 2 goes into 2 once, and 2 goes into 6.4 3.2 times. That'll make less stuff I have to type into the calculator here in a minute. Now I'm going to bring up my calculator. I'm going to say 8.1 times 3.2, and now we know the area of that base is going to be 25.92, and that's going to be meters squared. Now we're going to jump over here to the volume. 1/3 times the base area was going to be 25.92 times the height. That's going to be that distance. The height of the pyramid is going to be 11. Now we can take and put both of those over 1s since we're multiplying fractions by a fraction here. And that means in the numerator, 1 times 25.92 is going to be 25.92. And when I multiply that times the 11, I'm going to end up getting 285.12, I think is what I saw there. Yep, in my numerator. And my denominator, 3 times 1 is 3, times 1 is 3 again. Now all that's left to do is take that 285 and 1200ths, divide that number by 3, and we get a final answer that the volume of that pyramid is going to be 95 400 meters cubed. We're going to jump back over to our answer key, put it in, says to the nearest hundredth, 95 400ths, check our answer, and it checks. This right here is showing your work. That is what I must see on each and every one of those problems. But what if we already know the volume and we need to find one of the missing dimensions in that shape? Well, we can do that too, and they have a video for us on how to do that.
To find a missing dimension in a three-dimensional figure when given its volume, first write the correct volume formula. The volume of a pyramid is equal to 1/3 the area of the base times the height. Next, substitute the known values into the formula. The volume is 180 cubic inches. The base is a rectangle, so the base area equals length times width, or 10 times 9. Finally, solve the equation for the missing dimension. Start by simplifying. Then use properties of equality to solve for the remaining variable. The height of the pyramid is 6 inches.
Now their way of doing it did work well. I still prefer to keep my base area separate from the volume when I'm finding it, and I'm going to show you when we work some of these problems the way I want to, exactly what I'm talking about. Well, after just spending about 10 minutes working on this problem, which I thought was a really ugly problem, I looked at it closer and realized, you know what? It really isn't that bad because of what they're asking for. So I'm going to jump back to where I was showing all my glorious supporting work. Isn't that beautiful? And I'm just going to go to a fresh spot here, and I'm going to paste in my image again. And when I paste in my image again, we're going to just kind of stick that off here to the side. And we're going to go back and ask ourselves to read the problem. Always a good idea to read your problem. The prism has a volume of 195 75 thousandths cubic centimeters. What is the area of the base of the prism? In other words, what is the base area? We're missing a height here. We don't care. They gave us other numbers we don't need. We don't care. All they want to know is what is the base area of this prism. So to find that out, I'm going to come over here and write my volume formula. volume is equal to base area times height. I'm going to say they told me the volume's 195.075, and the height is right here, the distance between the parallel trapezoidal bases. So that's going to equal to the base area times 7.65. Super easy now. Isolate the variable by dividing both sides by 765. 765. These divide out becoming 1. 1 times the base area equals base area. And now I'm going to grab my calculator. I'm going to say 190. Let's try that again. 195. Let me actually clear that. Now 195.075 divided by 7.65. And when I do that, my base area is 25.5. That is the same exact thing that the textbook came up with. They did their work a little different than I did, but not really even a whole lot different. So right there, 25.5, oops, 25.5. Check your answer. That's going to be the base area. They're not looking for the height. They're only looking for the base area. It's really important to read your questions before you work the problem. Now it's going to be your turn. Solve this problem. Check your answer. Don't make it harder than it has to be. Problem tells us a triangular prism has a height of 9.3 centimeters and a volume of 74.4 cubic centimeters, and they want to know what is the area of the base. In other words, what is the base area? So we're going to come over here to our scratch paper and we're going to write down our formula. Volume is equal to the base area times the height. We're going to plug in what we know. We know the volume right there is 74.4 is equal to the base area times the height is given to us right there, 9.3. We're going to divide 9.3 on both sides. These divide out to become 1. 1 times the base area is the base area. And then we got our 74.4 divided by our 9.3, which means we're looking at a base area of our triangular prism is just going to equal 8. That's it. 8. It's almost anticlimactic at this point. I'm going to come back over here, plug in 8 square centimeters. Uh-oh, maybe it's not 8. Hold on. Dang me. I totally missed. We're not dealing with a prism. We're dealing with a pyramid. And because we're dealing with a pyramid, I have to use a totally different formula. Don't make my goober mistakes. So let me start over again with a whole different color and say the pyramid formula is 1/3 times the base area times the height. Now we're going to put in our 74.4 is equal to 1/3 times the base area, and the height was 9.3. I can take and simplify here, and this is going to look a little funky, but you can do that. 9.3 over 1, and you can simplify all the way across. 3 goes into 3 once, 3 goes into 9.3, 3.1 times. So now you're looking at 74.4 is equal to 1 times 3.1 is 3.1. 1 times 1 is 1. 3.1 over 1 is 3.1. And the base is still there. Whoops, I changed to blue. Oh well. Now we're going to take and divide both sides by the 3.1. These divide out becoming 1. 1 times my base is my base. And then I'm going to take and put in 74.4 divided by my 3.1. And that gives me 24, a totally different answer than what I got last time. So let's try again. We're going to put in 24. Check our answer. This time we got it right. For example number 5, we're taking it even further. This time they give us the volume and they give us the dimensions of the base, but they want us to find the height. That's going to take a little bit more work. Now the volume is 675 inches, square inches. Actually that would be cubic inches because that's volume. So I'm going to jump over to my work page and I'm going to go ahead and write 675 in for the volume. 1/3. Now I have to find the base area, and the base is going to be a square because it's 15 by 15, and the formula for the area of a square is s squared, or side squared. So base area is equal to 15 squared. Base area is equal to, I think that's 225, but my brain is really tired now. It is like 4:30 in the afternoon and I've taught all day. So let's do that squared. It is 225. So now I can take that 225 that I found right here and I can plug it in right there. And then of course I'm going to take that and multiply it times the height. Now I can simplify before I do anything else, and in simplifying I'm going to say that 3 goes into 3 once and 3 goes into that number. That's going to be 73 times, I believe, but you know what, let me go ahead and check my math because like I said, I'm tired. So 225 divided by 3 is going to equal to 75. See, it's a good thing I went back and checked my math. I'm going to write a 5 right there. And then from there, I can take and rewrite that just to make it look cleaner. 675 is equal to, now I have 75 times the height. Because 1 times 75 is 75, 1 times 1 is 1, and 75 over 1 is 75. Last thing I have to do is divide 75 on both sides, and this is going to get us our height. 75 divided by 75 is 1. 1 times the height is the height, and then we have 675 divided by 75, and that's going to give us the height is going to end up equaling 9. Jump back over here to our textbook, and you can see that when they worked it, they ended up getting the same answer I did. You can plug it in there if it makes your heart happy. I'm not going to do that. And now we're on our last problem. I know this stuff's kind of hard, but I want you to give it a good try. The wedge of cheese that is the shape of a triangular prism has a base length of 2.5 inches, so that's going to be this base length right here, and a base height of 4.75 inches. So that's going to be this distance right here, the height of the triangle and a volume of this. They want to know what is going to be the height of the cheese wedge. Go ahead and pause the video and try and work on this. As a hint, find the base area first, the area of the triangular piece, and then plug it into your volume of a prism formula. Okay, I've set up my problem. First thing I want to do is find the base area of the triangular piece. So that's going to be base area is equal to, this distance right here is 2.5 for my base, times my height is this distance right here, which is going to be 4.75, all divided by 2. Now I have choices how I want to do this, but I can see some real simple simplification here where I can take and say 2 goes into 2 once and 2 goes into 2.5 1.25 times. I can do that easily in my head, and now all I have to do is say the base area is going to be that 1.25 times the 4.75, which means we're going to get 5.9375. 5.9375. Now we can come over to the volume formula. Let's go ahead and circle that sub-answer. Volume we knew right here is going to be 11.875. 11.875. We know that the base area is going to be 5.9375. And we know that the height is what we're looking for. Super simple. Divide both sides by the 5.9375, and it's only simple because we're using a calculator on these. 9375. These divide out becoming 1. 1 times the height is the height, and then from there I'm going to take and go back to my calculator. I'm going to put 11.875. I'm going to divide it by 5.9375 equals, and the answer is 2. Which once again, that's a pretty anticlimactic answer right there. 2 is what we're going to get, so that means that this number right here, the height, is going to be 2 inches. I'm going to jump back over to my textbook, plug in my 2 inches, and check. And that is the end of a very long and brutal lesson. Do your best on your homework tonight. I'll probably offer some extra time to answer a few extra questions tomorrow in class because we had a lot of hard stuff here. Hopefully the homework will not be as hard as the lesson was. I'll see you in class tomorrow.